Hello students, today we are going to discuss the two hinged arch topic. Now what do you mean by two hinged arch? The arch which is having hinge support at the ends is known as two hinged arch. It does not have any hinge at its crown. So this two hinge arch is statically indeterminate structure to 1 degree. Now if we are going to calculate the degree of indeterminacy for this arch due to hinge support at A and B, we will have two reaction at A, that is vertical and horizontal, as well as two reaction at B, that is vertical and horizontal. So we have total 4 external reaction, and we know that for arches we will have only 3 equilibrium condition. Now if we are going to calculate the external static indeterminacy, then it will be equals to R minus S, so it will be equals to 4 minus 3, and the two hinge arch is statically indeterminate structure and the degree of indeterminacy will be equals to 1. Now this degree of external indeterminacy can be determined by taking the horizontal reaction as the redundant. Okay. Now here a two hinge arch is shown whose support A and support B is hinge, having reaction VA HA at support A and VB HB at support B, and is subjected to 2-point loads of W1 and W2. Now from the observation we will see that total number of reaction component will be equals to 4, that is HA, VA, HB and VB, and total number of equilibrium equation will be equals to 3. So we will get degree of external static indeterminacy as 1. So the structure is statically indeterminate by 1 degree, which we had already seen. Hence we need a compatibility condition to solve the indeterminacy of the structure. Now to solve this indeterminate structure we need one compatibility condition. Now vertical reactions can be determined through equilibrium conditions only. We will be able to determine the vertical reactions by the condition of equilibrium only. So from the equilibrium condition, that is the first condition, that is summation of all the forces in vertical direction is equals to 0. So we had written here, that is summation of y will be equals to 0. So VA plus VB is equals to the total downward force, that is W1 plus W2, that is our first condition. Similarly, taking moment about A equals to 0, we will have minus VB into L. Minus sign is because of anti-clockwise movement, plus W1 into A because W1 load is acting at a distance of A from support capital A. So this will be W1 into A plus W2 into L minus B, because this distance is L minus B. So the moment due to W2 load will be equals to W2 into L minus B, which will be our second condition. Now VA and VB can be determined by equation 1 and 2. By solving equation 1 and 2, we will have only two unknowns, that is VA and VB, and we will have two equations, so we can easily determine the value of VA and VB. Now to find the horizontal reaction, let us assume it as redundant. For finding the reaction HA and HB, we need to consider these reactions as redundant force. Now we will use our next equilibrium condition, that is sum of all the forces in the horizontal direction is equals to 0. So HA minus HB will be equals to 0. Therefore HA is equals to HB and it is taken as redundant force H. Okay. Now to find the redundant force H, we need to find the value of m dash y upon EI into dx whole integration 0 to L upon integration 0 to L y square dx. Now here m dash is known as beam moment. Now beam moment can be determined by taking the vertical forces only. Now to calculate the beam moment along a particular section, we need to consider only the vertical forces for finding the beam moment. Now by calculating the value of integration m dash y upon EI into dx Upon integration y square dx, we will get the value of redundant force H. Now in this way, we had determined all the reactions in our two hinge arch, that is HA, HB, VA and VB. That is all about the two hinged arch. Thank you very much, students.